In this lesson, we're going to explore the graph of the logarithm function. We're going to know the basic shape of it, along with its domain, range, and asymptotes, specifically looking more at the domain, and then we're going to apply transformations to that logarithm function. First, though, we need to make sure we know that shape and where it comes from. So we're going to start off with our basic function, log base 2 of x, and we're going to fill in this table right here. I'm going to start over here where things might be a little easier, and let's just plug in log base 2 of 2. So when x is 2, I'd say, well, 2 to the first equals 2, so there's a 1. Log base 2 of 4, 2 to the second equals 4. Log base 2 of 8, 2 to the third equals 8, so that's good. Log base 2 of 1, I could say, oh yeah, 2 to the 0. Log base 2 of 1/2 is going to be negative 1 because that's the power that puts the 2 in the denominator. Log base 2 of 1/4 would therefore be negative 2. And I'm seeing that pattern, and here we go. There's negative 3. So let's plot these points. At 1/8, way close to the y-axis, I've got negative 3. At 1/4, I've got negative 2. At 1/2, I'm at negative 1. Then I go through 1, 0, 1, 2, 1, 4, 2, and then out here to 8, 3. And when I connect these dots, like so, I have the shape of log base 2 of x. As it turns out, every log function looks like that, no matter what its base is. So it doesn't matter if its base is 2 or 4 or e or 10, they all have this shape. So looking at this graph, we can see that the domain actually starts at 0. We have no values to the left here. So 0 to infinity. For the range, we notice that it goes down forever. And on this end, of course, it also goes up forever. So negative infinity to infinity. Our asymptote this time is a vertical asymptote. Our graph never crosses this line, which is at x equals 0. And as we trace our graph from right all the way to left, we can see that we're continually increasing. And lastly, it always goes through the point 1 something. So if we explore this, log base a of 1, we would say, well, a to what always equals 1. Well, a to the 0 always equals 1. So that's a 0. And that means that every single log graph, no matter what its base, always goes through the point 1, 0, unless we've started shifting it. But if there's no shifts, it always goes through 1, 0. All right, now we're actually going to do some shifting. And so here we're going to state the transformation, sketch the graph. We're going to include where that point 1, 0 ended up and the equation of our asymptote. All right, in this first one, we see x minus 1 inside parentheses. So we're going to say, okay, this one is going to shift right 1. That vertical asymptote that was here before is also going to go right 1. And so I'm going to draw the dashed line. It is going to be at x equals 1. That point 1, 0 moved right 1, so it's now at 2, 0. And now I just draw in the shape. It doesn't matter what the base is. The shape is always the same. All right, let's try this next one. When we have a negative out front, you'll recall that it flips over the x-axis. Now I'm going to just draw in what our original was to reference. And so that when we flip over the x-axis, I have something to look at. It helps out. So that was the parent function. And now I can see when I flip over the x-axis, it's going to do this. That point 1, 0, I'm still going through it. And my asymptote is still right here at x equals 0. All right, let's look at our next one. This time the negative is on the inside. And when it's on the inside, it flips over the y-axis. So if I go back and draw in that original natural log graph like this, I know that when I flip over the the y-axis, it's going to do this. And that point 1, 0 that was here is going to land over here at negative 1, 0. and my asymptote is still here at x equals 0. All right, and our last one over here, we have 3 plus log base 5 of x. We can see that it's going to shift up 3. Our asymptote right here, when we shift it up, is still going to be right on the axis at x equals 0. But that point 1, 0 is going to go up 3. And so it's going to actually be at 1, 3, not at 1, 0. And then when we draw our curve, it's going to do something like that. All right. So the other big thing about these curves is that the logarithm can only take positive numbers. Remember, look back to the graph. Our domain only has positive numbers when it's x. And so when we have something like this, we know that this inside part, x minus 7, has to be greater than 0, which means x has to be greater than 7. And I find this number line helpful to change it to interval notation. So I'm just going to highlight the part that's greater than 7. So that's this part. And now I can see easily that my answer for the domain is that it's going to be from 7 out to infinity. Let's try another one here. My inside, this has to be positive, so 2x plus 1 must be greater than 0. 2x must be greater than negative 1, and x must be greater than negative 1/2. Again, we get our visual, and we can shade everything that is greater than it. So that's going to be everything out here. And so now we can write our answer that our domain goes from negative 1/2 out to infinity. Now we've got some slightly tougher problems over here. And so what we have in this log graph is we have two things on the inside. And so we're going to consider them separately and then together. So I've got two number lines down here. And before I go any farther, remember when I'm dividing, a positive divided by a positive is positive, but also a negative divided by a negative is positive. So those are the two places where I can get that positive number on the inside. All right, so let's start with the x plus 1. X plus 1 greater than 0 means that x has to be greater than negative 1. So I'm going to plot a negative 1, and I know that it is positive up here, green for positive, and pink for negative, okay? And then I can do the same thing with x plus 5. X plus 5 also needs to be greater than 0, so that means x has to be greater than negative 5. Here's negative 1. I know negative 5 is below it, so I'm going to go right there. And I know that it's positive when I'm bigger than negative 5, and it's negative when I'm less than negative 5. And now I can see my answer. Remember, they're both positive up here in the green, and they're both negative at the pink. And we can see that right here we've got two negatives, and right here we've got two positives. So our final answer for the domain is from negative infinity to negative 5, but also from negative 1 to infinity. Because from negative infinity to negative 5, I had a negative divided by negative. And up here, past negative 1, I had a positive divided by a positive. All right, so our next one is very similar, only we need to factor first. So we've got the y equals log base 2 of x squared minus 2x minus 8. And when we factor this, we get x minus 4 times x plus 2. And like before, we need to get two things positive. So let's bring down two number lines, and we'll take the first one being when x minus 4 is greater than 0. That means x has to be greater than 4. So here's 4 right there. And our second one is when x plus 2 is greater than 0. That's going to be when x is greater than negative 2. So here's my negative 2. I know that they are positive up here when I'm greater than 4 and greater than negative 2, because those are my answers here. I know they're negative from here to here and here to here. And then I can see my final answer, that they are both negative right here from negative infinity to negative 2. And they are both positive from 4 to infinity. All right, I think you're ready